Topic: torque and angular acceleration. The relationship between torque and angular acceleration. To discuss the relationship between the torque and angular acceleration, we consider one rigid body with large number of point masses. Okay, here this rigid body is rotating about the fixed point. Here we consider one of the point mass. The point mass is not a by letter m. This point mass execute the circular motion. Okay, in a rigid body, here it is rotate with the fixed point. We consider one of the point mass. So the point mass is also execute a circular motion. When the rigid body is moves about the point, here this mass is execute a circular motion. Now a tangential force, this is a force at the point mass. The force is making the angle is 90 degree, so this is a tangential force. The tangential force is acting on the point mass. This mass produces a rotational motion. It is produce a rotational motion. Okay, so the tangential force is acting on this. There is execute a torque. Due to the torque, here this point mass is also rotate. It is execute a rotational motion. Here this force F vector is perpendicular to the position vector, that is r vector. This F vector is perpendicular to the r vector. Okay, that only I told here the F vector is making the angle is 90 degree. So from this we are going to calculate the torque produced by the force. The torque produced by the force on the point mass. On the point mass m about the axis. About the axis is calculated by using the formula of tau is equal to, already you know the formula, r vector into f vector. Tau vector is equal to r vector into f vector. We are going to calculate the magnitude, so tau is equal to r, it is making the angle 90 degree, so r f sin theta. So tau is equal to r f sin 90 degree. Okay students, already you know what is the values of the sin 90 degree? Sin 90 degree is equal to 1, so we can write tau is equal to r into f. Okay, according to the Newton's second law, we know that f is equal to m into a. When the force is acting on the mass, it executes a circular motion. Okay, so from the equation of motion, from the Newton's second law, we can take f is equal to m into a. Okay, so it is substituted in this equation, tau is equal to r into ma. F is equal to ma according to the Newton's second law, so we can write tau is equal to r into ma. And then when the external force is applied on the body, it is execute a circular motion, and this body it is also execute a acceleration. That acceleration is one of the angular acceleration. So already you know the relationship between the linear acceleration and angular acceleration. The angular acceleration the linear acceleration a is equal to, the linear acceleration a is equal to r into alpha. Alpha is the angular acceleration. So we can write a is equal to r into alpha. R means there is a perpendicular distance, alpha means there is an angular acceleration. So when the external force is applied on the body, it is execute, the mass is execute a circular motion, that is a rotational circular motion. So there is execute acceleration is one of the angular acceleration. So we know that relationship between the linear acceleration and angular acceleration, that is a is equal to r into alpha. So it is substituted in this equation, means this equation is modified to tau is equal to r into m into r into alpha. In next step, it can be written as tau is equal to m r into r square alpha. Okay students, so in vector notation, we can write the tau vector is equal to m into r square alpha vector. Here the direction of the r and alpha, the direction of the tau, not r, the directions of the tau and alpha are acting on the same direction. The direction of tau vector and alpha vector acting on same direction means and it is also along the axis of rotation, okay. It is acting on the same direction and it is also acting along the axis of rotation means here there is produce a angular acceleration. This rigid body is produce a angular acceleration. Suppose here the directions of the tau vector and alpha vector are not in same, it is acting in opposite direction means about the axis there is produce a acceleration, there is a negative acceleration. That negative acceleration is called retardation. So what is the meaning for retardation? Retardation means there is a negative acceleration. Okay, here the directions of the tau vector and alpha vector is not in same, it is acting opposite direction, so that is called retardation. And then in this equation tau vector is equal to mr square into alpha vector. So we are calculated for the torque for the mass m, point mass m. So the rigid body, it is made up of the large number of particle, large number of point mass. So you can calculate the total torque act on the rigid body means the total torque act on the rigid body is calculated by using the formula of tau vector is equal to summation mi ri square. Okay, so summation of mr square alpha vector. Right? So in next step we can write the tau vector is equal to, what is the meaning for m into r square? Already you know the product of the mass and the square of the distance is equal to moment of inertia. So the summation mir square means that is a moment of inertia of the body. So we can write the tau vector is equal to I into alpha vector. So this is a relationship between the torque and the angular acceleration. This is the relationship between tau and alpha. Okay friends.